Hey YouTube, I'm Jonas. Welcome back to my channel. Today we're going to solve the question 200.
Number of islands.
So we're given an n by n 2D binary grid, which represents a map of ones and zeros. So 1 represents the land and 0 represents the water. So we need to return the number of islands. Island is surrounded by water and is formed by connecting adjacent lanes horizontally and vertically. So we can also assume that all 4 edges of the grids are all surrounded by water. All right, so the first thing you should do is not trying to write any code, but just, look at the picture and try to get as much information as you can. So if you are, giving this picture to a kid and tell them to count the island in this picture, how are they gonna do this? So let's say we start at the up left cell, and then we want to draw an outline of the island, right? So basically we may draw this whole area, and then we may take a look at its adjacent neighbors, like this one. But this one is already the part of the island we draw, right, in this area. For all other ones in this area, we are not gonna count them twice. So we basically just get rid all of them. So let's look at some other zeros. This is the island, this is water. This is the island, it's water. This is water, this is water, this is water. And all of this is water, 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 water. And at this cell, it's 1, right? So this is out of the area we drew in the previous island. So we will, count it as a valid island. Then we will include all the other ones connecting with this adjacent neighbor. Basically, these 2 ones will form another island. So at this time, the number of islands in this picture is 2. Now we kind of have an idea of how this algorithm works, but it may feel a little challenging if you know a little bit about graph algorithms, like how to determine these areas as the valid island and how to mark if this, element has been visited or this being included in the previous area. So they are all like common techniques for graphs. So we're gonna take a look how to implement this. All right, let's start from the top left element, 1. Basically, the condition to form an island is that to check its adjacent neighbor. If it once, we will continue check if the neighbor of the next element is once. We will keep going until we meet the first 0. So basically for this given 1, we will check its neighbor. We will look into 4 directions because the adjacent lanes are defined as connected horizontally or vertically. So basically this, up, down, left, and right, right? So for this top left element, because left and top are out of boundary, we will not consider them. And so the first we will check its right neighbor, and it's 1, so it's valid. And the bottom is also 1, so it's also valid. So then we will check adjacent neighbors of these 2 red circled elements. And for this element, we will see that right neighbor is also 1, so it's also valid. And the bottom neighbor is 1, so it's valid. And for top neighbor, because it's out of boundary, so we will not count it. And for the left element, it has been visited, so we will not count it either. So basically, if we circled a cell, it means that we have visited it. So for the top left one, I will use black to circle it. And then for this one, we will check its neighbor. So the right neighbor has been visited when we visited this one, right? So we will not visit it again. And for the top element, it's visited. And for left, it's out of boundary. So we will just visit bottom neighbor. So it's also 1. And it's also valid for the length. Then we will check like this one, and its right neighbor is 0, so it's not valid length. and we will not get into consideration. And for the bottom direction, it's also 0, so not in consideration. For this one, the right neighbor is 0, so not in consideration. And for the top direction and the left direction is also visited, so we will basically just visit the bottom direction. And that's valid 1, so it's the length. And for the last one, the top and the right directions have been visited, and the left is out of boundary, and bottom direction is 0, and it's not the length. So basically, we have visited all the valid ones in this area. So it's called the breadth first search, BFS. So remember, what have we done is basically to check the nearest neighbor of the given cell. So for the top left one, we basically check the red circled neighbors instead of going straight right to this orange circle or going straight down to this orange circle. Like we first check the left and the red circled ones, and then these 3 red circled ones, and finally the last one. It's just like 4 layers in this area, and we use the breadth first search to check every directions for the visited length. In this way, we could guarantee that we have visited all the possible lanes connected with the formed island. So once we visited the top left element, we will iteratively visit every connected ones with this top left element. All these 4 layers will be visited, and we will determine that there is a formed island. And then we will basically continue our traversal for this grid, and we will cross out the 0 ones. And for the second row, these 2 elements have been visited, so we will not count them and cross out all the zeros. Same thing for this row. And then we come to the last row, and the first 3 elements are all zeros, and we'll cross them out. And for this one, literally the same thing as the top left one. So we will first consider 4 directions of this one, and the right one is a valid length, so it will be taken into account. And the top direction is 0, and left is 0, and the bottom direction is out of bound. So we end our exploration for this one, and then we know that these 2 form another island. So after we visited every element in this grid, we will know that we have determined all possible islands in this grid, and we will return 2. So we will see how we're gonna implement this in code. All right, so let's code it up. What are we gonna do is basically implement the breadth first search, and I think the structure or skeleton is, reusable for many other problems. So it's very important to grasp the basic idea of how we implement this BFS. All right, so we will first from the collections import the deck, which is the implementation of queue in Python. And we will use it to store elements of different layers. First, if this grid is empty, we will return 0 to indicate there is no island in this grid. And then we need to traverse the whole matrix. So we need to know the length of rows and columns. All right. Also, we need to have a set or a list to record the cell that we have visited. So we will use the set to implement this. And also, because we define adjacent lanes as horizontal and vertical, so we will first define 4 possible directions. And we will have a CNT variable, which is going to be 0 initially to record the number of the valid islands. And then what are we going to do is traverse the whole matrix. So first rows, basically it's a nested for loop. We will conduct BFS, for every I and j. If this element has been visited or this element is 0, we basically do not need to conduct extra search for this element, right? So if this position has not been visited, the value at this position is not 0, we will conduct the BFS for this position. One thing to remember is that the 0 here is a string, not a integer value. So it can trick you a little bit. At least it tricks me, and I waste like 5 minutes to debug and finally find it's a string, not a integer. So then we will return the CNT, which is counting the number of the islands. So the whole skeleton is this, and we need to actually implement this BFS. So the input argument will be INJ, which is the position of the current element we're visiting. First, we will have a queue implemented by deck. Initially, it will have the position of INJ zipped as a tuple. So we will continue going until this queue has no element in it. If you have visited my video about the tree, you will remember that breadth first search in the tree, we also use a queue to implement this. So basically they apply for the same idea about using queue to implement this. And then we will get the current position of this front element in the queue. We will just pop out this element. Then we will check if this position is in the visited set. Basically, we visit for the first element, we will check several elements that has not been visited. Same thing for like the element in the middle. We may have checked several elements before it, and the current one may be the part of the current island. So this condition ensures that we will not count the same element twice to make the algorithm more efficient and eliminate some potential bugs. Since it's not been visited, we will edit it into the visited set. And then for this element, we will check for directions to see if there is any adjacent neighbors which is linked. So we will traverse every direction in directions. And the next position will be the current I coordinate plus the first element of the direction. And the current J coordinate will be the second element of the direction. So remember, if we are visiting the element in the first row, we will not explore the top direction, right? Because it's out of bound. In code, we'll also check this. These two conditions ensure that we will not be out of bound. Another condition that the value in the next position will not be 0, which means the next element should not be the water, not further explore this element. If all these conditions are satisfied, we will append the next position into the queue. Then we'll pop out the next element and conduct the same process. So basically that's how we implement BFS in code, and let's see whether it works. Oh, we forget to increment the number of count. So we successfully find a 1. Even if it's just a single one, we would know that it's a valid island. So the count should be incremented by 1 if this conditions are satisfied. So let's see whether it works again. All right, so basically we finish this.